Hello, welcome again, and in this lecture we will be discussing about the symmetric key distribution. In the previous case we have seen symmetric key agreement between two parties. In this case we will be discussing about third party center that basically helps in the distribution of the key. And let us see why is that third party required. So symmetric key distribution involves symmetric key cryptography, and in symmetric key cryptography you know that you need to have a secret key that has to be shared between the two parties. The problem is that if there are n number of people, then each person needs n minus 1 keys to communicate to other person. So the total number of keys that are required is n into n minus 1 divided by 2. Divided by 2 signifies that two people are using the same key. Therefore, such a huge number of keys are required, and this problem is called as the n square problem, because if we see that there are 1 million people to whom Alice wants to send a message, then Alice needs to share the key with 1 million people, which is a very tedious task. Therefore, we need to have a solution for the distribution of keys, and that solution is the trusted third party, which is called as the key distribution center. So this key distribution center is a center to which all the users would be connected, and this will help in creating the session keys between the users who want to send messages to each other. So this KDC is the one that is in between. Every user is connected to the KDC. So here you will see that Alice is having a secret key with the KDC, that is KA, Bob has got KB, and other users have got their respective keys. If Alice wants to send a message to Bob, then in that case Alice cannot directly contact the other user of the KDC, but all the requests should be directed through the KDC. So Alice will contact the KDC and will tell KDC that Alice wants to send a message to Bob. It is KDC that somehow connects to the Bob, and if Bob agrees, then a session key is created between Alice and Bob. This session key means that for that particular session, a key would be generated. If the session is ended and later on again Alice wants to send a message to Bob, that means a new session has been generated and that session is supposed to have a new key. Therefore, the same process would be repeated over and over again, and this is done by KDC for all the users that want to communicate to each other. Now here the problem is that when the number of people increase to a very great number, which actually is a great number in the real internet scenarios if we talk about, then one KDC cannot cater to the need of all the users. It will be a very time consuming process. Therefore, the work is distributed among several KDCs, and this is called as multiple KDC approach. This multiple KDC approach, you'll see that every KDC is connected to every other KDC in a flat architecture or a peer manner. If Alice is belonging to KDC1 and Bob is belonging to KDCN, then Alice will contact its immediate KDC and will tell that Alice wants to send a message to Bob, and this KDC will figure out that to which KDC is Bob connected. These two KDCs will help in the creation of the secret key or the session key, which will be used in the communication by Alice and Bob. To better this architecture, a hierarchical multiple KDC architecture was proposed where the users are connected to the local KDCs, which in turn are connected to the national and international KDCs. So if Alice and Bob belong to two different countries, so Alice would be contacting its immediate local KDC. That local KDC will relay the information to the national KDC, and then it gets relayed to the international KDC and relayed down to Bob. And once it reaches the Bob, the immediate KDC of the Bob and the KDC of the Alice will be helping in creating the secret key between the two. Just have to keep in mind that the keys that we are talking about are not the keys that are valid for lifetime, but these are the keys that have been created for a particular session. Once the session ends, the key also ends. Next time a new key would be generated. Now let's discuss about the distribution of these keys. One of the simple protocol is that the overall scenario is that Alice wants to send a message to Bob, and KDC is helping in generation of the key. And this signifies that KDC and Alice have got a secret key between them. KDC and Bob has got a secret key between them for the exchange of messages. Now, if Alice wants to send a message to Bob, there is no key in between them. Therefore, the message that they want to send will not be confidential. So, Alice will contact KDC and will tell that I am Alice and I would like to connect to Bob. So, the two identities are sent to the KDC. KDC will respond back to Alice, and the response will be encrypted by the secret key KA that they have in between themselves, and the content that it has is represented by the red. The content is the session key of Alice and Bob, that is KB, along with a ticket, and that ticket contains a message for Bob, because this message, the content of the ticket, is encrypted by KB. Alice cannot read this message because Alice does not know KB. This gray portion can only be decrypted by Bob, right? So this is called as a ticket which Alice has to send to the Bob. But you have to see that when decryption takes place at the Alice's place, Alice immediately comes to know about the key, session key between Alice and Bob. The next step is that Alice will send the ticket as is to the Bob. When it gets delivered to the Bob, Bob will check that it gets a message that is encrypted by KB. So it decrypts it. When it decrypts the message, the Bob would realize that it gets an identity of Alice and a session key. So it immediately confirms a message to Bob that Alice would be contacting the Bob with the session key KAB. And therefore, in this fashion, the key is getting exchanged between the two interested parties. The other technique is a Needham-Schroeder. In Needham-Schroeder, the first three steps are the same, that Alice contacts the KDC and says that she wants to send a message to Bob, and then KDC replies back with an encryption with KA, the key that is shared with the Alice, and with the data part of this message is the session key between A and B and a ticket for Bob, and Alice sends that ticket to Bob as in the previous case. But here there is an additional step. The additional step is that once Bob decrypts the message and Alice is authenticated to the Bob, now Bob would send a message to Alice, an encrypted message using the session key with a random number. There is a benefit for this. The benefit is that after this message, Alice is now confirmed that Bob is also ready to communicate. In the previous case, we were not able to tell whether Bob is ready to communicate or not, but yes, the message has got delivered to the Bob. That is another thing. But now it has been established that the Bob is ready to communicate and has posted a challenge to the Alice. And now Alice will respond back with the response. And this response is supposed to be a number less than the random number that was given previously. And the requirement to do this is because we don't want any third party to replay the same message again. So if this message was intercepted by the intruder could have replayed back it to the Bob, right? In order to avoid that, it is necessary that Alice should reduce the value of the random number and then send the message back to the Bob. Once this message is at the Bob, now Bob is also confirmed that Alice is ready to communicate and even the keys are working properly, which has been shared by the KDC. Had this not been done as was in the previous protocol, then there was a problem. The problem was, let's go to the previous protocol and you'll see that this message could have been stored by an intruder. An intruder could be sending the message to the Bob, and every time Bob received this message from the intruder, which is actually the replay attack, Bob would be like that there is Alice who wants to communicate to Bob without realizing that every time the session key is coming out to be same. And we said that session key should be different for different sessions. So without realizing that, Bob will get fooled in assuming that Alice wants to communicate over and over again, although this is not the case. right? So to avoid that, Needham-Schroeder had included these two steps as well. It is serving you two purposes. It is not allowing the replay attack to happen, and both the parties have now confirmed that they are ready to communicate to each other using the session key KAB.